One important modeling rule in SAFE strip foundations is this. If a design strip is placed at an angle relative to the global X and Y axes, you must also rotate the local axes of that strip. One local axis should follow the longitudinal direction of the strip, and the other should remain perpendicular to it. If you do not rotate the local axes correctly, SAFE may generate inaccurate meshing, incorrect force distribution, and unreliable reinforcement design results. Now let's compare these two models. In the model on the left side of the screen, the local axes are rotated and aligned with the strip direction. But in the model on the right side, all local axes remain aligned with the global X and Y directions. Next, we run the analysis for both cases. Notice that the finite element mesh changes completely, depending on the local axis orientation. In the left model, the mesh follows the strip angle, because the local axes are rotated correctly. But in the right model, the mesh remains aligned with the global X and Y directions. This difference directly affects internal force distribution and reinforcement calculations. Now let's compare the reinforcement results. Assume the continuous reinforcement is 14 mm bars, and the additional reinforcement uses 16 mm bars. In several locations, the reinforcement demand changes noticeably between the two models. For example, in one area, the right model requires 3 top bars and 1 bottom bar, but the correctly rotated model requires 4 top bars and 2 bottom bars. In another location, one model requires 2 additional bars, while the other requires 3. Even the reinforcement development lengths are different, because the theoretical and practical cutoff points change. This means incorrect local axis orientation does not only affect bar quantity, it also changes reinforcement length, anchorage zones, and detailing requirements. In some projects, the difference may be small, but in complex foundations, the error can become very significant. So always remember, whenever you model an inclined strip foundation in SAFE, rotate the strip local axes to match the strip direction. One final note, continuous strip layers are also important. SAFE recognizes continuous reinforcement paths based on strip continuity and layer assignment.